Okay, so just want to talk about some basic cartography ideas, and hopefully it won't take too long. So in some basic ideas we'll talk about the types of maps and what they're used for, right? So certain maps, color-coded maps versus like other kinds of maps. Like if you watch the Weather Channel, they have all kinds of cool colors, and those colors represent like value and things like that. And that's kind of what we're heading for with that. And we'll talk about the actual features of the data of the map and the other stuff, right, which is called the marginalia, all the stuff that goes around the margins, north arrow, tidal area, and all that kind of stuff. So, all right, so we can categorize or at least break up the two kinds of maps, basically. There's reference maps, which allow you to, well, it's good for reference, right? You can refer to it for data, right? Then the other ones would be to show information rather than just data, I guess. So thematic maps allow you to make sense of the data a little bit more than what you would consider a reference map, I guess. So they're typically used to, like it says here, to show how data is related to each other, right? So what is it? The first law of geography says that things that are closer to each other are more related or more similar than things that are further away, right? So if you think about it, if you want to, like temperature, thinking of the Weather Channel, right? So if we had two cities that were just a couple miles apart, right? Like Kirtland and Farmington or something, then you would expect their temperatures to be pretty similar as opposed to like here in Denver or something, right? Yeah, right. So the further it is away, the less relevant their data is to each other, right? So that's an important concept, because when we want to weight that data against each other, you know, the further it is away, the less weight it has, kind of thing. So that's an important concept too. So we can show the themes or these patterns or these relationships with a variety of symbologies, right? And we've already kind of talked about, and we've used them already, right? We use different dots for different, for just different, like we had hospitals have one dot, a different kind of dot as the fire stations or whatever, right? Airports and things like that. But we can also just change its color by its value, right? Not just by the type. So although type is a different value, I would say, not just a numeric value. Okay, and then we can also use labeling to help us decipher that data. So, good enough. Okay, so as far as how a map is labeled, this is the anatomy of a map, if you will. The three basic parts are the body of the map, which is where you see the data or the features of the map, and then you have the supporting data, such as the title and the legend and the north arrow and scale, data citation, projection information, name, date, right? I mean, that's kind of a lot. And that takes up a bit of room, as we saw in our last map. Trying to put all that stuff in there is not so easy. And then you have the symbology of it, where we take the body of the map and make it look a certain way to show those relationships here. So, all right, so here's a precipitation map, right? And so you can get an idea pretty quickly that the darker values, and we'll talk about color in a minute too, but I'll go on before I get too far into that. As far as the marginalia stuff, basically outside the body, you have just what we mentioned. Anything else we missed? You can use borders to help decipher all that marginalia too. You can separate that data to make it easier to read with what we call neat lines and borders. You can inset other maps, like there's a map on the wall right off to the right that has the map of the United States. Actually, I'll show you this one, right? So this is, you know, Alaska right here is not actually right there, right? It's removed from its normal position, and the reason for that is it's too far away and it's too big, right? So it's shown in a convenient location at a different scale, and we're still okay with that because it obviously looks like Alaska. We didn't even have to label it or anything, right? So your audience means something too, I guess, in that case. So we don't have Hawaii. Oh yeah, Hawaii's right here. So we have 2 maps. We actually have 3 maps in here, right? And these are called inset maps, where they're just kind of removed at a different scale from the other map. And sometimes you can show.
It looks like they're still scale.
Yeah, I don't think. I mean, yeah, I think this is at a far. I mean, Hawaii is at a far greater scale than the rest of the U.S. and Alaska is at a smaller scale than it. I think. Yeah, probably. Anyway, yeah. And so, what if I wanted to show like a particular county in the United States or something? And so I might show like a little box around the county that I want, and then I might show some the edges of it coming out here, and then the actual county would be inset there too. So that would be another way to show, although that line would go to the other corner, wouldn't it? Okay. Anyway, you get the idea. So we see maps like that sometimes, where you have the U.S. being a reference, and you can say that county is kind of right there, and so I can, that gives me more information. So okay, good. There are different elements here. This actual slide is designed to talk about the title of the map. So this is actually a decent title, even though it's not so huge. A lot of times, a common mistake is to give the title too much size, right? The title doesn't have to be overwhelming, right? It just has, it's actually the largest text on the page still. And it's not overbearing, right? I mean, it's easy to see, it's easy enough to see, and it's not overpowering. So that's a decent title there. Okay. It should be positioned so you could read it easily, and it also, that your choice of title helps the reader understand what they're looking at. So that's kind of like it's your first line of your first impression for the map. Maybe it's the second. I mean, when I look at this, I see a nice purpley map, right? And then I look at the title. So that's kind of the second thing you see sometimes. So good. All right, this is way too much stuff for the legend, but you saw how much legend stuff we had to work with to make it look good, right? So ArcGIS helps you make a nice looking legend, but it takes a bit of work. Like you have to change. Usually when you put the stuff into the data into your map, it's gonna have file names for your table of contents, right? And so those file names will bleed into your legend if you don't change them. So, and that's a bit of work. I mean, it just takes time to change all that when you do that, which is easy enough, but you just got to remember to do it, I guess. Yeah. Again, the size of the legend should be large enough. The symbols should also be the same size, right? So if I have a dot in the map, the dot in the legend should be the same size as in the map, which isn't always easy to do. But aerial features like lakes and borders of states and things like that, they don't have to be the same size, obviously. So same color though, right? But ArcGIS already takes care of that for you. Most softwares do anyway. So okay, so yeah, the legend you should be able to. The legend can stand on its own, right? For the most part. I mean, it explains itself, so you don't have to. I mean, there's nothing else that's going to explain it for you. Okay. And keep in mind the purpose of the legend is so for clarity and legibility of the whole map. So that's what it's there for. And that'll help you determine what goes in the legend, right? So you don't want to add stuff that's, you know, like a state boundary. If it's pretty obvious, you can leave it out, things like that. So, so if you need to interpret the legend at all, it's not a good legend. All right, well, yeah, you know, any GIS is going to give you a plethora of north arrows to choose from. Some are super fancy and all that. It should lend itself well to the purpose of the map, right? If the purpose of the map is is for aesthetics, then you can put a flowery north arrow in there. But if it's like an engineering map or a construction map like that, then maybe a simple north arrow ought to do. And again, it shouldn't be overpowering or divert your attention away from the map, right? It should be in there so you can see which way which way north is, because north is not always to the top of the page, right? It could be at some angle, and that could be useful to know. So scale bar, there's 3 basic scales that we can talk about, and I always want to do that, but and we talk about scale a lot, but generally you have a scale bar, which is a graphic representation of scale, and that's good for like road maps and things like that, where you can actually see the size and relate it to the map. Other ways, like in engineering maps and things like that, you would just want the numbers, right? So an absolute scale is just a 1 to something, and it's unitless, right? So in this case, I have this example of 1 to 24,000, written with a colon or a forward slash. That is a unitless thing. So 1 inch on the map is 24,000 inches on the ground, which, by the way, is a typical topo map, and that's 2,000 feet. So it also lends itself well to a verbal scale, which I skipped here in the order of things in this slide. A verbal scale uses units, right? So 1 inch is 1 mile, things like that. That's good to just mentally interpret, because you know basically where a mile is or how long a mile is, even if you don't know in your mind how far that is. You know how long it takes to traverse that amount of time, you know, that distance and things like that. So we're pretty hardwired for those kinds of common sizes. So you would never want to see a scale like 1 inch is, you know, 2.8 miles or something like that, because that's harder to interpret, right? The idea of this is for clarity. So, all right, good enough. Borders and neat lines, they should not distract the reader, but they should block out stuff, so you can, not block out, but block things in, I should say, where the body of the map, in this case, we have a nice border around the entire map, but then we also have a neat line or a border around the body of the map, as well as the title area and the marginalia stuff. So we've neatly, right, those neat lines help us to categorize, if you will, mentally these things, these elements of the map. So nice. Okay, we already talked about inset maps pretty well. I guess we're okay with all that. So good for putting other maps at different scales, basically, other elements or features of the map at different scales. Say what? Yeah, so we have a map. Yeah, so this is a map of the Four Corners area, right? And then we have a small map. This is not a very good. This would be, you know, you could zoom in on just the continental US or even just the western part of the US, and that would be at a better scale. But you could also see that where you're looking at the larger part of the map, where that is in the smaller scale map. So that's the idea of it, although this isn't a great example of it. Okay, other information you might want to put in your map. Like who prepared it, right? So you didn't create, most of the time you will not have created all the data in the map, but maybe you'll have created some of it, right? So the author is more like the map is prepared by, and then you would have a data citation like citing where the rest of that data came from. Your organization, dates, production dates even, projection information like we did before, the coordinate system, that's kind of automatic now, so that's nice. And other information that you would need for that may have been associated with that map. So, okay, so when you're planning a map, these are some of the things that help the map keep its focus, right? So the objective of the map, like why are we making this map other than because it's an assignment, right? So we kind of want to, a lot of that in the class is sort of fictitious, I suppose, but yeah, we'll getting long in the tooth here, so let me run through it. So we want to keep the purpose of the map, the audience of the map, right? So if you're going to use this map as a presentation, right, maybe you'd want to fit it to the resolution of the projector, right, and have nice colors that will transfer nicely. If this was going to be printed out to lots of people in black and white, then you got to just worry about contrast rather than color, perhaps. So that's where the audience, or where that's going, right? So, and that also goes into how big the title is, how big the labels, the text of the labels are. I mean, that kind of pervades the entire, all the elements of the map. All right, so that's where we talk about technological limits of the output. And where the map's going to be seen, right? If it's going to be on a wall, then at a higher scale, like a big scale map, or if it's going to be in a magazine at a much smaller scale, then you'll that'll affect how the elements of the map are displayed. Last little bit there, the sensitivity. Like if you have like archaeological sites, that's sort of sensitive information, right? You don't want people going in there and damaging or vandalizing or stealing, you know, pots and artifacts, as it were. So, as well as land ownership, like there's widely available tax information on the web, you know, putting that out for everybody to see is probably insensitive. Not illegal, but probably not a great idea. All right, we'll talk a little bit about aesthetics. I'll try to get through this a little faster, but we'll talk about visual balance, perception, and the symbology itself, where that's actually the nuts and bolts of it, I guess. So just keep in mind that the visual center of a map or any kind of document is graphic, I should say, is about 5% higher than the geometric center of it, right? So I could find the geometric center of a rectangle just by drawing the diagonals of it, such as drawing this across, right? And it's, whoops, just skipped it. Anyway, its geometric center would be where those diagonals actually crossed. And so the visual center would be about 5% higher than that, as far as the height of the map goes, 5% of the height. So that's something, because that's where our eyes normally go, a little bit higher in the center. So there you go. We've already, you know, used color, and computer algorithms have different ways to show or to choose color. Most devices, like your phones and the screens and projectors and things like that, are considered RGB devices, red, green, blue devices. Maybe you've heard of that. Maybe not. Anyway, because they're RGB devices, they can only show red, green, or blue. Okay, but they can show it at the same time, so they can mix that color and get you different colors. Well, most of them are 8-bit devices, right? Or, well, 24-bit really, but each color is 8-bit. So I have 8 bits of well, 2 to the 8th different shades of red, which is 256, right? 2 times 2 times 2 times 8 times is 256. So I can get 256 different shades of red and green and blue, right? And so as far as combining those, well, if you take statistics, that's combinations, right? So 256 times 256 times 256 gives you all the possible colored combinations you can have, which is around, well, what, 2 to the 24th, right? which is about 16.7 something million colors, which is enough, right? I mean, that could show just about what you want for a map anyway. Okay, so the way you choose that, right? So if you go to a color picker in like Photoshop or ArcGIS, it shows you some palette colors, which are just some colors that have names associated with them. Or you can dig a little bit further and go into further properties and choose the 3 basic things where you have hue, saturation, and lightness or value or brightness. Sometimes it'll be HSL, HSV, or HSB. Sometimes it's abbreviated that way. Hue refers to the wavelength of the light, right? So, you know, this mouse pad, I would say it's blue. And now I'm talking about its hue, right? That's the wavelength that it doesn't absorb, right? That it reflects back. And it's absorbing most of the other light. So all the red light that's coming out of these lights that let me see this gets absorbed by this material. And it reflects the blue, so I get to see the blue, more or less, right? So that's hue. And the saturation is how pure that color is, right? If it's bleeding in with a bunch of other red and greens and things like that, then that makes it less pure, if you will. So a bright blue, I don't want to say bright because that's the other value, right? So we call it purity. So pure blue, as opposed to bright blue or dull blue, right? So a dark blue, light blue, that kind of stuff is your lightness or value to it. Each of these has 256 values also. That gets translated into the RGB anyway. So that's one way to do it, or you could just pick the amount of red, amount of blue, amount of green that you can do with it. And that's another way to choose your color. All right, so that's that. All right, you got 4 minutes. When you pick like fill items, like for areas, when you fill something with a color, sometimes you can use a pattern which can extend the amount of differences you can see. Like, so if we're symbolizing population or something, and you use just one color, you can only discern about 7 different shades of a single color, right? A single hue. So to extend that, you can go to different hues, which you can, the human eye can about see 12 different colors or hues, right? You can extend that a little bit more with using patterns, but you want to avoid what's called texture vibration, right? Patterns that make you dizzy, if you will. Yeah, like the center one, right? Or even the, you know, I think all of them are somewhat dizzying, right? And that's an important thing. That, you know, if you go to Las Vegas and look at the carpet at the casinos and things like that, they use this kind of pattern to disorient you a little bit, so you make poor decisions, I guess. I don't know. So, yeah. Yeah, exactly. And realize that the you know, about 5% of the population is colorblind. All right, let's see if we can get through some of this. All right. As far as symbology goes, we want to use colors that mean like what do I say, that are conventional, like blue, water, right? Red, warning, or maybe they're big roads or something like that, right? That we're kind of used to. More earthy colors, or like browns and pastel kinds of greens and things like that, for vegetation and whatnot. So yeah, so the more pure a color is, the bigger the value it describes, and the brighter it is, the more value it describes. So pastel or muted colors will sit back in the background, which are very useful, right? So you want to use those. Grays, lighter grays and stuff like that can sit back in the background and let the other brighter colors stand in the forefront, right? So we can also use transparency to help that as well. Okay, I think we can stop here. So we already spent quite a bit of time with the layout view, like laying out the map and stuff like that, and we'll spend more time with that as we do it. So I think I can stop here. We can also just keep in mind that the software also allows you to import charts from the data, right? So if we had, I don't know, precipitation, we could make a chart based on the precipitation data that you have or something. So you can include reports and charts in your maps as well, which is kind of fun. So yeah, right. The more we do it, the better off we're gonna. Yeah, exactly. Yeah. Well, or because we have a drought. Yeah. Okay, so I'm gonna pause it here and we'll call it a day.